Good morning and welcome to my laboratory. What you're looking at there is sine waves. Pretty good sine waves. There's a little bit of a ripple, as you can see, in the first 90 degrees of the phase, and then there's also a little bit in the 180 to 270 portion of the phase too. But it's certainly not bad. Both of these traces are being viewed at 20 volts per scale division, and both of these traces are from the exact same points on the transmitter board. We're looking across the drains, and I've got both probes hooked to the exact same point so that I can show that the channels are at least equalized. There's a little bit of difference in the two probes that I'm using. One is a modern Velleman probe, and the other one is an old original Tektronix probe there. Okay, so the probes are slightly different, but what I've done is I've adjusted the calibration knobs on the vertical amplifiers to give those traces exactly the same height, since they're coming from exactly the same place on the circuit. So I'm going to just overlay them there a little bit, and so you can see that we've got the same signal, same height, same amplitude. Okay, and make sure we got that back in the right place. Sorry about that. Okay, so baselines are in the right place, right on that gradical marker. Okay, there we go. Okay, so this is the transmitter output across the drains. Nice sine wave. And we're giving as input power, what I've got here is I've got the battery, but in parallel with the battery, down here, I have a variac controlled DC power supply that's a brute force DC power supply. So I'm using the battery as kind of a buffer, and I'm applying enough voltage with that DC power supply to keep the input voltage at about 13 volts. I need to crank that up just a hair. I got one hand on the variac, one eye on the voltmeter. Okay, so with the circuit operating, all right, I want to have a voltage of about 13 volts, and I don't want it to really sag much during the demonstration. Okay, and then here we're looking at the current to the transmitter, and then here we're looking at the waveforms. And what I'll do in a moment is I'll disconnect the bottom probe and hook it to the receiver. Okay, but first what I just want to show is the receiver, or rather the transmitter waveform. So right now we're 17 centimeters apart, and that little bulb is glowing fairly brightly, and we've got an input current of 1.51 amps and a voltage of just slightly over 13 volts. Okay, so now what I'm going to do is slide this bulb in, and we're going to pay attention to the brightness and the current. Okay. Okay, now it's in supernova mode now. Watch the current. Current's going down as I get closer. As I get further away, current goes up. And the brightness of the light doesn't change in this range. Okay. Until, boom, it drops out of supernova mode and the brightness goes down. Alright, so now it's not in supernova mode. You can see that the current goes up with proximity and down with distance. And now it's being reluctant to shift into the supernova mode. Alright, so let's go back to our 17 centimeter distance there. And let's get our probe transmitter, which is over here. Let's put that in there. And let's see if we can induce that supernova transition and have it stay. Oh, it's the law of the lab. When you try to do a demonstration in public, often it fails. Okay, there you go. There, now it's in supernova mode. And as I move closer, the current actually goes down. And as I move further away, the current goes up. And the brightness of the light stays pretty much, almost exactly the same actually in that range, until I get far enough away so that it drops out and goes back to the normal mode. And now it's in the normal mode, and it won't make the transition until I do it with the probe receiver. And I also have to be in the right spot with this receiver. Whoops. Sorry. It's like I'm juggling. It's easy to get this one into supernova mode. There we go. Okay. So now what I'd like you to do is to look at the scope traces. And I think you can see from just the general illumination what mode the light bulb is in. Okay, so remember that both traces there are from the same point in the transmitter. So we just dropped out of the supernova mode. You can see as I move in and out, the frequency changes, the transmitter's frequency changes a little bit, right? In and out. And then when I initiate this, by the way, we're looking at that at 0.5 microsecond per division, okay? And then here, if I put in the probe, boom, that's the supernova transition right there. Boom. Okay, so you can see that at the supernova transition, there's a shift in the frequency. Boom. Right? And then if I can get it to stay in the supernova mode, like that, now when I move in and out with the receiver, oops, sorry, it just dropped out. There. Now when I move closer with the receiver, the frequency doesn't change. I'm moving in and out. Frequency changes just a little bit, but not anything like what it was doing before, until I get to that dropout point, and then we get that abrupt transition. Okay, so now what I'll do is I'll remove one of those scope probes from the transmitter, and without changing any settings, I'll put it onto the receiver, so I can do it without dropping or breaking anything. Okay, so now I'm going to get the probe entangled. All right, now we're looking at the receiver, just right across the bulb there, or the capacitor, and we're looking at those at the same scale. You can see a little bit of distortion now in the receiver's sinusoid, and that I think is because my loop is not symmetrical. Okay, so now I'm going to use just the probe to drag the receiver closer, and hopefully we'll get a supernova transition in there like we did at that point. Okay, so now look at the scope traces. We're triggering on the top channel on the transmitter. Bottom channel is the receiver. So you can see there's a little phase shift, right? Well, I mean, there's a 180-degree phase shift, but there's a little bit more than a 180-degree phase shift. Otherwise, those peaks right there would be coincidental. We're in the supernova mode now. And as I go further and further away, boom, there's the dropout. Closer, closer, closer. Come on. Come on. Further, further, further. Closer, closer, closer. Still no supernova yet. There's a supernova transition. Now further and further away, there's the dropout. Okay? I hope that explains a little bit, at least describes a little bit about the behavior of the system. Let me get this transmitter trace at a good display resolution there, so you can see how clean that sinusoid is. That is beautiful, and it's skewed a little bit. That may just be because of the probes, and there's just a little bit of noise here in the first in the first 90 degrees of the phase. And that's it. Thank you for watching.